Today we're going to talk about the items cluster tool in DFR. The items cluster tool is an advanced module in DFR that allows you to look at batches of parts and analyze them in order to find duplicates and near duplicates. You can use this tool and its powerful analytics to review sets of parts and find cost savings or extra parts that may not be needed in your environment. To use the items cluster tool, enter DFR. On the left-hand side, you'll see this icon. Click it and it'll open the items cluster tool. Once you're in the items cluster tool, the first thing you need to do is select a batch. You can do that using this dropdown. Once you've selected a batch, it will load up into these two grids that you see here. The top grid is used to assign weight factors to each of the individual attributes. And the bottom grid shows each part, its item number, its qualifiers, and any attributes that have been selected. We'll go over how to change the weights and see different attributes in a moment. Up in the top section, you'll see that I have a number of attributes marked as critical. These are generally the key attributes that go along with that segment of the data. Here you can see we are looking at a batch of circuit breakers, and we have selected the AC voltage, the current, frequency rating, and some of the physical dimensions such as height, length, and width. Looks like I have a couple attributes that don't need to be in here. If I don't care as much about the manufacturer part name, part number, or plant number, I can deselect these items, and you'll notice that they are moved over to the left. I also noticed that these all have weight factors. What the weight factor does is that determines how much value is placed on a duplicate and near duplicate for these items. As these attributes are all string attributes, meaning they are non-numerical and can contain letters, they are not as good at clustering as our numeric attributes. If I would like to remove them from the cluster analysis, I can select them, right-click on these, and select 0 to zero out all the weight factors associated with these. Once I've made that change, I can hit my Calculate button, and you'll notice the data reloads on the bottom grid. Once I've loaded the data on the bottom grid, we'll notice a few things. First of all, you'll notice that a large number, actually all that you can see right now, all of these parts are bolded. If I scroll down, you'll see that there are some that are not bolded beneath. The bolded items are all part of a single cluster. You'll see here in the third column, there's a column called neighbors. This shows that for the part selected, how many near matches or matches there are in the system for duplicate parts. The next column, distance, shows how close they are to the original part. For example, this item has 600 volts, a current of 77, a height of 5.4 inches, a length of 3.1 inches, and a width of 2.83 inches. You'll notice that immediately below, I have a part that has a distance of 0.4. That means it is a near duplicate, but not exact. This part, as you'll see, has a height of 5.8 inches. Because this is within our determined range, this is allowable as part of the cluster. This part may be within the given give of any given circuit breaker that you need to deploy. So you can see that these two parts are very close. If I select another line, you'll notice that the numbers change. Now, this line has a distance of 0, and the line above has a distance of 0.4. Selecting different items will allow you to see the distance from each individual item to its neighbors. This can then be sorted by clicking any of the columns in the bottom grid. If I click the distance, for example, that will sort all of the items pertaining to their distance from my new item number. If I look down, you'll see that there are the non-bolded items. These are our additional clusters. The easiest way to find the next biggest cluster is to sort by our neighbors and scroll down. You'll notice that this cluster has 30 different parts that are within our given neighbor distance. Below that, I have a cluster of 17. If I click on any one of those 17, they all become bold. I can then sort by distance in order to quickly pull these up to the top and see them instead. You'll notice that the first handful of items all have a neighbor distance of 0. These are all exact duplicates on the factors that we weighted upon, which are voltage, current, frequency rating, height, length, and width. However, they may have different values in other areas, such as unit cost, manufacturer, part number, or even plant location where they came from. You can see very quickly that in this batch of 17, there are roughly 10 parts that are identical, yet their unit costs are vastly different. You can use this information to figure out what parts you should be buying and from where. Now, let's play around with some of the numbers and see what other information we can find. I'll resort this to bring my biggest batch to the top. As you can see, we have a varying number of distances from 0 all the way up to 0.4 for this particular part. If I were to change the weight factors of some of these items, you'll see those distances change. For example, if I think that the height is a more important attribute than any other, I can give it a larger weight factor. Let's say 3. Once I click calculate again, it will recalculate the data. Notice that within my tolerance of a 2 neighbor distance, I still have 30 neighbors. But if I sort by distance again, you'll notice that some of these items are much larger. For example, this bottom item is now 1.2 distance away. This is because the height is further than any other height, being 0.4 inches away, as opposed to many others which are simply a fraction of an inch. You can use this in concert with the neighbor distance to trim down your parts in order to find exactly what you're looking for that meets your specifications. So now, if I lower my neighbor distance to 1, you'll notice that that part has been removed from the cluster. And now, based on my top item number, I only have 29 neighbors. Some of the lower items, you'll see, have different neighbor numbers because those individual parts touch less based on their current data. So if I were to select this item with only 27 neighbors, some of the items on the far end of the spectrum get removed. Worth noting that for numeric attributes, we take into factor the actual numbers, their decimals, and any slight pieces of information. Those all get calculated with the weight factor, allowing us to do this. Using a string attribute, such as frequency rating, however, is much more binary. We detect either that there is a match or there is not. So using more numeric attributes is going to make your clusters a lot cleaner. The last thing I'll show you is how to export these. If I click the export button, this will export the file to a fixed location on my hard drive. The file is located in the Convergence Data Services CDS Toolset Clusters folder and is a tab-delimited text file that you can open up in Excel. This is the example that I had before of my 30 parts. You'll notice that this exported the 30 parts in the selected batch and all the columns associated with them. I can see the distance and other information as to where they were located and the factors that were involved in the clustering.